Why NASA believes Europa could harbor alien life. Imagine a world where the sun is nothing more than a distant pinprick of light, where the surface is frozen solid, colder than Antarctica, bombarded relentlessly by radiation powerful enough to kill anything exposed to it. A place that looks completely dead. And yet, beneath that frozen shell, there may be a vast, dark ocean. An ocean that could be alive. This is Europa, one of Jupiter's moons. And according to NASA, it might be one of the most promising places in the entire solar system to search for alien life. Not Mars, not the moon, not even Saturn's rings. Europa. Tonight we're uncovering why scientists are taking this frozen moon so seriously. What clues convince them something extraordinary may be hiding beneath the ice, and how humanity is finally preparing to find out what's really down there. A moon that should be dead. At first glance, Europa looks hostile in every possible way. Its surface temperature averages around -170 degrees Celsius. There's no breathable atmosphere, no liquid water on the surface, and it orbits deep inside Jupiter's intense radiation belts, where unprotected electronics, let alone life, would be destroyed. For decades, scientists assumed Europa was frozen solid and lifeless. But then they noticed something that didn't make sense. The cracks that changed everything. When NASA's Galileo spacecraft flew past Europa in the late 1990s, it sent back images that stunned researchers. Europa wasn't covered in craters like most moons. Instead, its surface was crisscrossed with long, dark fractures stretching thousands of kilometers across the ice. The surface looked strangely young, as if it were constantly being reshaped. That shouldn't happen on a dead world. Geologists realized something was happening from below. A ghostly magnetic signature. The real breakthrough didn't come from images, it came from invisible forces. Galileo carried instruments that measured magnetic fields. As it passed Europa, it detected something strange. Europa appeared to generate its own magnetic field, interacting with Jupiter's powerful magnetosphere. The only explanation that fit the data? A global ocean of salty, electrically conductive water beneath the ice. As Jupiter's magnetic field sweeps across Europa, it induces electric currents in that hidden ocean, creating a secondary magnetic signal that Galileo detected. It was like hearing an echo from a sea no one could see. This wasn't speculation anymore, it was physics, a world with an ocean beneath ice. Today, scientists believe Europa contains a global subsurface ocean holding more than twice the water of all Earth's oceans combined. That ocean lies beneath an ice shell estimated to be 15 to 25 kilometers thick. It sounds impossibly deep, but in planetary terms it's thin. More importantly, the ocean isn't frozen. Because Europa has a secret energy source, how Jupiter keeps Europa alive. Europa doesn't orbit Jupiter in a perfect circle. Its orbit is slightly elliptical, constantly stretched and squeezed by Jupiter's immense gravity and by the gravitational pull of neighboring moons. This constant flexing generates heat through a process called tidal heating. It's like bending a paperclip back and forth until it grows warm, except on a planetary scale. That heat keeps Europa's ocean liquid, and possibly much more than that. Fire in the darkness. On Earth, some of the most resilient life thrives in total darkness, around hydrothermal vents on the ocean floor. These vents don't rely on sunlight, they rely on chemistry. Superheated water, rich in minerals, pours out of the crust, feeding ecosystems built on chemical energy rather than light, a process known as chemosynthesis. Scientists believe Europa's ocean floor may host similar vents. If that's true, Europa wouldn't just have water. It would have energy, chemistry, and time, the three pillars life needs. The ingredients for life. As far as we know, life requires three things. 1. Liquid water. 2. Chemical building blocks. 3. A steady energy source. Europa appears to have all three. Water, A global ocean. Chemistry. Observations have detected salts, sulfur compounds, and carbon dioxide on the surface, likely originating from the ocean below. Energy, tidal heating, and possible hydrothermal activity. Even Europa's deadly radiation may help, creating oxidants on the surface that could eventually be transported down into the ocean, fueling chemical reactions. In a strange way, Europa's harshness may actually feed its habitability. Water plumes, Europa breathing into space. Perhaps the most tantalizing evidence comes from water vapor plumes. Multiple observations suggest Europa may occasionally erupt geysers of water hundreds of kilometers into space. If confirmed, this would be extraordinary. It would mean future spacecraft wouldn't need to drill through kilometers of ice. They could simply fly through the plumes and sample the ocean directly. Taste the water, search for organic molecules. Which brings us to NASA's next move, Europa Clipper, humanity's deepest investigation. Yet NASA is no longer guessing. The Europa Clipper mission, launched in October 2024, is now on a 5.5-year journey toward Jupiter, scheduled to arrive in 2030. Its mission is precise and cautious. Europa Clipper will not look for life directly. Instead, it will answer a more fundamental question. Is Europa habitable? Because habitability comes first. How Europa Clipper will explore a dangerous world. Europa is surrounded by intense radiation, too dangerous for long-term orbit. So Clipper uses a clever strategy. It will orbit Jupiter, not Europa, performing 49 rapid flybys of the Moon. Each pass will last only hours, minimizing radiation exposure while collecting massive amounts of data. During these flybys, Clipper will pass as close as 25 kilometers above the surface, close enough to see features the size of a tennis court. Its instruments will map nearly the entire surface in high resolution, scan for warm regions and active geology, analyze surface chemistry and faint gases, measure Europa's magnetic field in extreme detail, use ice-penetrating radar to search for hidden lakes and map the thickness of the ice shell. If Clipper flies through a plume, it may directly sample material from the ocean. Not life, but the conditions for life. Why Europa may be more promising than Mars. Mars once had water, but lost it. Europa never had to protect surface oceans or a thick atmosphere. Its water is hidden, shielded, protected beneath ice. For billions of years, while Mars dried out, Europa stayed wet. That stability matters. What if life exists there? If life exists on Europa, it likely won't be intelligent or technological. It would probably be microbial, simple, slow, ancient. But even that would change everything, because it would mean life arose twice in one solar system. Life is not rare, and life doesn't need Earth-like conditions. The quiet implication. There's something unsettling about Europa. If life exists there, it's hidden, protected beneath ice, silent. It doesn't broadcast its presence, and that echoes a deeper idea. Maybe life in the universe survives not by shouting, but by hiding. What comes next? Europa Clipper is only the beginning. Future missions may include landers, ice-penetrating probes, subsurface explorers. Each step brings us closer to answering one of humanity's oldest questions. Are we alone? Europa may not answer loudly, but it might answer quietly. From beneath the ice. Final thoughts. Europa looks frozen, silent, and lifeless, but appearances can deceive. Beneath that ice may lie a living ocean, older than humanity, deeper than imagination, and waiting in the dark. If life exists there, it tells us something profound. Life doesn't need sunlight. Life doesn't need Earth. Life finds a way. And perhaps the universe isn't empty. Perhaps it's just quiet. Final call to action. If this journey to Europa changed how you think about life in the universe, subscribe to Cosmic Insights. We uncover the mysteries hiding beyond our world: black holes, alien theories, cosmic paradoxes, and the future of space exploration. Leave a comment and tell us, do you think life beneath Europa's ice is more likely than life on Mars? Because the search is no longer about if life exists, it's about where we'll find it first.